Okay, Dr. Wosfi, are you here?
Yes, I'm available. I'm waiting for you.
Thank you so much. Let us just a few minutes and then you can start.
Okay, I'm ready.
Thank you. Hello, everyone. Thank you so much for everyone who participated in this online webinar. Okay, today we are so proud that several people are participating in this webinar. Around 170 people have been participating in this webinar. The people who are participating in this webinar, most of them, they are from Pakistan, Cyprus, Afghanistan, Ethiopia, Taiwan, Philippines, Algeria, Cameroon, Zimbabwe, China, Germany, Bangladesh, Malaysia, Cambodia, Sri Lanka, Nairobi, Laos, Nigeria, Somalia, Tunisia, United States, United Kingdom, and Iraq. I'm going to introduce a little bit about our STAT office, the STAT Office for Statistical Data Analysis and Training. As usual, we're going to say something about our office. Our service would be including how we're going to find the exact title for the researcher, or how we could collect the data for the researcher. It depends on the researcher might be student in bachelor or master or PhD. In both source of data, it means in primary source data or secondary source data. Also, we are available for cleaning the data and then analyzing and interpreting data. Also, in this office, you can find the perfect journal for your paper. Means if you do have the paper, you can find the journal for you. Also, we're going to consult for the companies. And also, we have several courses, especially in Microsoft Office, plus SPSS and our program, which this program for the researcher or statistician. Also, we do have several statistics courses, depend on the university of company that required for us to teach them or taught them. Also, in this office, we do have the online webinar in every single week. For today, we are so glad that Dr. Wosfi accept our invitation to present the seminar entitled How We're Gonna Choose the Best Statistical Analysis in Statistics Using SPSS. Dr. Wosfi, he is assistant professor in statistics department. He has been working and serving several years in statistics department at the Salahuddin University. Now he is a vice president of administration and finance at Tishk International University from the Kurdistan region in Iraq. Also, he has been supervising several PhD and master students. Now, we're gonna ask Dr. Wosfi to start his presentation around 40-45 minutes. And then we're gonna open the doors for your questions. If you have any questions, you can raise hand after his presentation is done. Dr. Wosfi, please go ahead to start your presentation.
Thank you very much. Welcome everybody, ladies and gentlemen. I'm really glad to participate in the other webinar with Stat Office. It's a pride of me. Could you, Mama Stajar, kindly mute everybody and give me the access for sharing, please?
Yes.
Yes. We want here to discuss some statistical tests using SPSS and how to choose them and why we need statistical tests it's obvious for everybody, for sure it's obvious for all of you, that when we want to, I'm sorry, I want to share something with you. Okay, let me share something else with you, and let's start one. Oh, could you kindly mute them, sir? Mute them, please. Thank you. Okay. Ladies and gentlemen, we know, everybody knows that when we want to start, let me, okay. As you know from previous info, that why do we need tests? Statistics is really important, but why do we need tests? We usually say when we want to study a population, if we have one population or maybe two or maybe more, what we intend to do is to work on the population. Sometimes we are not able to study the whole population, so we are forced, in that case, to take a sample, okay? So when you take a sample, it means that you want to use this sample to represent the population. But somebody may say, okay, how can I know that this population is represented by this test? So what we are trying to do here is we want to study the sample, and what sort of studies of the sample we want to make, we will infer it to the population. We simply want to use the statistics that is took from the samples in order to infer about the population. Okay? Okay. Now let's continue. So we wanted to test the statistics that is calculated or obtained from the samples, and we want to infer to the population. Okay, somebody may say, how many samples I have? How many populations that I have? What is my main objective of the study? Why do I need to work on a sample? Okay, what are the statistics that I want to use for me to infer about the population? Sometimes we need to make, let's say, an inference about the mu or mean of the population, or the variance of the population, etc. If we have one population, gives a meaning, and if we have two populations, gives another meaning. So in this case, what is my main objective? The main objective is going to give us what test statistics that is most proper to use. In other words, if I suppose that the majority of you, ladies and gentlemen, is familiar with the SPSS, right? If you have any sort of problems, for me, I'll be more than happy. Let's continue, ladies and gentlemen. I'm going to share this data with you. This is an SPSS file. We have collected the data here from somewhere else, and I want to share this for you. I suppose that everybody is looking at this data. This data is actually talking about the disease called thalassemia. Thalassemia, major, minor, and there are some healthy people. It depends on the main objectives of our research. If we are intending to compare the average of one of the variables with a sample with a specific value, for example, I want to know what is the average of, let's say, white blood cells. Here in this example, the white blood cells, I have a variable here called white blood cells. So I go to analyze and choose compare means and choose one sample t-test and choose the variable that I want. For example, we said let's choose the white blood cells. So I'll take the white blood cells to this window, then I'll give it a value. Let's assume that value is 100, although 100 is too much, but let's say 75, for example. So what we're going to do, we are going to compare the data that I have in this example and compare it with this 75, whether I'm going to get good results or not. I'm going to share the results with you and let's discuss it. Okay, now what we get, we have first of all, I have n, which is 234. The mean is 21.0404, and the standard deviation is 25.74968. But that's not the test itself. The test is the t test. Value is minus 32.056, but what we care more about is the p-value. You can see, ladies and gentlemen, that the p-value is 0.000. It means it's very highly significant. In other words, the value that we have determined, which was 75, of course, this is a rough number, 75, the population or the sample that I'm studying is far behind this figure that we have determined, which was 75. In other words, there is a highly significant difference between the data that I am using, the mean of the data of white blood cells compared with 75. So, as you all of you know, that this is very highly significant. So if it's under 5, 1, or 10, whatever, and that all of these is significant. So maybe we have done a mistake in choosing the value of 75. Let me assume that we are not taking 75. Let's take 25. 25. Let's see the difference. Let's go and share the result for you. Here you are. Now, ladies and gentlemen, if you notice, oh, it's still significant. It's 0.019. So it's still significant. So it means that the value is still significant. Okay. Now, what we learned now a moment ago is how to make a one sample test. But how about if I have two sample tests? It means I'm having two samples or maybe two different groups. For example, I have gender here. Let me make if the comparison, if there is a comparison between the groups, let me do it. But we go to analyze, we go to the same compare means and choose the two independent t-test samples. We are going to group them according to gender. I have a code of gender 0 as female and 1 for male. Then I have the weight, blood. Oh, let's choose the same thing, the white blood cells, and press OK. Let me share, ladies and gentlemen, this output with you. Okay. So this is the output. According to the output, ladies and gentlemen, you notice that the p-value here is non-significant. I have 0.126 for equal variances and 0.125 for not equal variances. In other words, I'm assuming the first value that both samples or both groups, males and females, coming from the very same group or from the same population. The other one, I'm not assuming that they're not coming from the same population. In other words, like I'm saying, that the males and females are different. But whatever the case here in this example, ladies and gentlemen, you notice that it is non-significant. So the value of the white blood cells, the mean of the white blood cells in females and males does not change. So this means there is no difference. Whatever any sort of differences that we may get, it is due to randomness. It's not significant. So what we learned now a minute ago, that we made difference between two groups, males and females. Now, how about if I have a difference, but this time between more than two groups, so we took one sample comparison and we took two. Now let's take more than two. In this case, we are going to use one-way ANOVA. One-way ANOVA, let's assume the group was the variable, and let me see the white blood cells again in the dependent variable. And first of everything, let me make one simple comparison and see the results, and let's discuss the results in details. Ladies and gentlemen, you can see that the ANOVA, one-way ANOVA table is the needed comparison for more than two samples. In other cases, in this example, in our disposal, and under our disposal has three, and the groups has the three different subgroups. They are thalassemia major and thalassemia minor, plus the healthy people. Now, according to the p-value of F, they are very highly significant. There are very highly significant differences among the three groups of those patients. Those three patients groups were, as we said, major thalassemia, minor, and healthy people. Somebody may say, so if there is very highly significant differences, I want to know between who and who. So what I will do, I'll go again to the ANOVA test again, but this time I ask for post hoc. Let's choose LSD. What is post hoc? Post hoc tests are those tests that are using multiple comparisons between those subgroups that we have chosen. One of them that we have selected, of course, every single one of those has its own specificity, and but generally speaking, let's choose LSD, which gives me the real difference, place, and why did this difference occur. So according to this, again, ladies and gentlemen, we notice that the ANOVA table is very highly significant, and ANOVA test is very highly significant. In case that this ANOVA test was not significant, we would not be able to choose the post hoc because we will not be needing it. As you notice, ladies and gentlemen, from the multiple comparison, we have thalassemia major compared with healthy and with minor. As you see, for both cases, we have very highly significant 0.0000 in the first two cases. So this means thalassemia major compared with healthy is difference, a very high, significant difference. Compared with minor, it's again significant difference. If you notice, ladies and gentlemen, on the screen, there is a star on the mean difference, a star. Any star means significant. If you find no stars, it's not significant. Where the non-significancy coming from is the difference between healthy and minor thalassemia. The rest are significant, if you notice, ladies and gentlemen. So this means that I did one test. That test was comparing three groups all together at the same time: thalassemia major, healthy, minor groups all together with ANOVA. First of all, when we saw the ANOVA p-value, the f-p value was very highly significant. We wanted to search why they are very highly significant. So what we did, we used a multiple comparison to find where the significancy is. We noticed that the major with all of them is very highly significant, while minor and healthy were not significant, which is really, I mean, expected for medical disciplines. They may know that this is true. Okay, now let's go to something else. This is comparison. Somebody may say, I want to see whether there are any sort of associations between different variables. So what I do, I go to analyze again, and this time I choose descriptive statistics. From descriptive statistics, I use crosstabs. From crosstabs, let's choose two variables: blood viscosity with white blood cells, whether these are related to each or not. Ladies and gentlemen, I want to draw your attention to the type of these two variables. Both variables, as you see, are scale variables. So this is why when we want to test for association, we have to click on statistics and see what is available. I want to draw your attention to the following one by one tests. The first one, as you see, is chi-square. Chi-square, I clicked on chi-square. Chi-square is used, ladies and gentlemen, when I have two variables. Both of them are scaled, interval, or measurable variables. The correlation can do the same, but the correlation is a weak test, but we prefer to use chi-square. I'm going to click on this and discuss a bit about the results, then we will come back again to this, okay? So I press continue, then okay, and let me share the results with you as well. Let's see what the reasons are, or what the result is. These are the two, the table that we call it the cross table, but let's see the most important thing, the result in the chi-square test. As you notice, ladies and gentlemen, the p-value is 0.000. This means it's very highly significant. In other words, this means that there is a very highly significant association between blood viscosity and the white blood cells. In other words, this relation is a non-causal relationship. It means there is a relationship, a non-causal relationship. We usually call it association. That's for chi-square. Let's go back again. Now, if we have two different type of variables, what to do? In other words, when you go back to crosstabs, these two, both of them are scale, but let's choose, instead of white blood cells, let's choose gender, for example. Now we have two different variables, and what we want to do here, we want to see, one of them is, as you see, is scale, the other one is nominal. When I go back to statistics, I don't use chi-square. Even some scientists do, but I don't use it since I have two different types of variables. I have nominal versus interval, so I'm going to use eta test. This is more preferable to use eta test. So continue, okay, and let me share the results with you. Now, what was the value of the test? Look, in this case, I have two results. One of them, blood viscosity is dependent. The other one is gender dependent. Both cases, whichever is a scale, of course, we know blood viscosity is the scale. This means that gender is not related to blood viscosity. In other words, how did we know that the association between gender and blood viscosity was not significant? If we go back and give a small note about eta test. Eta test is a test that is used, or that is prescribed, when we have two different variables. One of them is scale, the other one is nominal. The value of the test itself lies between 0 and 1. Whenever it exceeds 0.5, some scientists prefer to say 0.6. Some scientists prefer to say more than 0.70, or sometimes 0.75. then claim that there is a significant relation or association between these two variables. But whatever the case here is, as you notice, ladies and gentlemen, both of them are non-significant. From our point of view, we know that the blood viscosity is the scale variable, so we will choose 0.043, which is non-significant. So in that case, we claimed none of them were significant. But what would happen if I have to choose different variables? Let's say instead of blood viscosity, I'm choosing blood groups. So blood groups and gender, both of them are, or not blood group, let's say group itself versus, okay, versus gender. So what I will do, I'll go to statistics, and instead of using eta, I have to use nominal versus nominal. The most common nominal versus nominal is the contingency coefficient. Ladies and gentlemen, as you see from the screen, we have other tests like phi, Kramer, V. We have lambda, we have uncertainty coefficient, whatever. If you see the other side, we have, let's say inside this small box, we have ordinal. It means gamma, Somers D, Kendall's tau, Kendall's tau B and C. These tests are used ordinal versus ordinal. Well, when you see these tests that we have chosen, one of them is nominal versus nominal. Eta is used when you are choosing nominal versus interval. Kappa, risk, McNemer, these are non-parametric tests. Okay, we will press continue. Now,
Okay.
let's see, so he's coming back again. Okay, so what we get here, ladies and gentlemen, as you see that I am having, for the contingency coefficient, it means 0.000, very highly significant. It means that there is a relationship between the gender and the thalassemia. Maybe this is, maybe the physicians may have their own words on that. But so far what we took the comparisons of one sample test, the one-way ANOVA. The same time we went to see the crosstabs for association. Now, for crosstabs association, all of the tests used here are all of them association of non-causal association. In other words, they are only a relationship with no reasoning or yes. Now, somebody may say, okay, how about if I have too many variables with one variable relationship? So we will choose regression. The simplest regression is I'm going to choose the linear. The regression is that specific relationship that is combining too many variables with one variable. Those variables affecting one variable is called linear regression analysis. Dependent. This dependent has another name, which is the response. So I would say, I would put blood viscosity here as the dependent variable. In other ways, it's the response variable, which is called blood viscosity. Now, somebody may say, what are the variables that are affecting the blood viscosity? Maybe if I am a biologist, I would choose too many variables. I'll choose the, let's say, red blood cells, and let me choose the density as well. Let me choose only these two variables and to see how this relationship is happening. Okay. Now, this is the result of what we got, ladies and gentlemen. I want to draw your attention to too many results here. Every result here is important, as you notice, ladies and gentlemen. Model summary. The model summary, I have R square, which is explaining for how far that these variables, independent variables, describe the blood viscosity. In other words, we have chosen white blood cells and density to describe or interpret the Y, the dependent variable, which was called the blood viscosity. Now, as you noticed, the R square or the adjusted R square value is very small. It's 0.019. So what is the role of the adjusted R square? The adjusted R square's role is to find for how far that these independent variables were successful in interpreting or explaining the value of the blood viscosity. But this is very small value, as you see, ladies and gentlemen. But we can solve this issue as well. So the next thing to look at is the ANOVA. ANOVA here, it means that I want to see for the different groups whether the this relationship or this model that I have chosen was really good. If this value was not significant, I would say, no, this relationship between blood viscosity and white blood cells and density of blood is not significant, or the model that you have chosen is not a proper model. It's a very bad model. So you have to find another model. But in this example, ladies and gentlemen, as you see, the value is 0.038, which is significant. When you say significant, it means that these variables, white blood cells, and density are really affecting the blood viscosity. But would you think that the effect of all these two variables are the same? Absolutely not. So what we mean by that is that every single variable has its own effect, which may vary from one to another. In other words, what is the amount of the effect of white blood cells? As you see, the effect of the white blood cells is minus 0.002. I would say, or some of the biologist colleagues would say, no, this is not correct. The relationship should not be negative, but whatever. Or maybe it's negative, who knows? They will have their words, not me. And how about the density? The density has a negative relation as well, which is minus 1.944. But let's see whether this estimation of beta minus 0.002 and minus 1.944 were both of them significant or not. Let's see the significance of the estimations. Now, for the constant, I have 0.000. It means that the constant is very highly significant. The blood viscosity, white blood cells is 0.261, so it's not significant. And the density is 0.014, it's significant. Maybe somebody would say, from the biological point of view, this is not correct. This should have been significant as well. So what to do? One of the reasons that the model that we have chosen, I did it from my own. So what I did, I went to regression, linear regression. I've chosen the constant, the beta naught. But if I remove the beta naught, I'll click on this. I'll choose options, From options, I choose, I click on include, remove include. What remains is like in the model, I have removed the beta knot. And let's see what the results would be. The results has totally changed, ladies and gentlemen. If you notice that in the model summary, the adjusted R squared and R squared is 96.2%. It means it has the effect of very highly, it's really high effect or interpretation. So now these two variables are really good implementing in interpreting the blood viscosity. 96% is really a high value. The other thing is, let's see the ANOVA. The ANOVA again was very highly significant. At that time was 0.38, but in this time it's 0.000. This time is very highly significant. As you notice, ladies and gentlemen, the residual mean square is 0.426. It's very small. If you compare the other one, it's 0.363. Then now this is 0.4. So, but the value of the mean square for the regression has increased. In other words, these two variables were really important in interpreting the blood viscosity. In other words, now both variables, white blood cells and density, has that high effect on blood viscosity. But as you see, ladies and gentlemen, for white blood cells, it's 0.000. Like it has not that, let's say, a noticeable effect on the blood viscosity as causal relationship. If you still remember, the other one was a causal, non-causal. The association was really significant, but this is not. So what would people advise us, since it's 0.783? It's non-significant. So it's non-significant. Somebody may say, why not removing the white blood cells from this relationship, which is something good? So we go back to linear regression, and in that time we choose again. This guy is preventing me from clicking. So what we do here, we remove the white blood cells from the model, and let's bring back the what do you call it? The intercept. Okay, we click on it and let's see what the results are. Look, again, it's the adjusted R square has declined. So it is 0.018. It's small again. But if you go to see the values of both of them, the p-value of ANOVA, while both of the variables, the constant and the density, was significant. But I am not a biologist. I'm choosing these variables from my own. But if biologists, according to their profession, they know which variable to choose, which variable not to choose. I would say we have took very fast tour in the tests that we have. We said we have comparison between comparing one sample, and the same thing we went to take the relationship or association between two variables, and we took all the cases when we have two different variables, both of them, if they are scale, we choose chi-square. If one of them was nominal, the other one was interval, we choose the eta test. When both of them are nominal, we choose the contingency coefficient test. And then we try to take, if we have more than two variables to compare, we have chosen the ANOVA from compare. And if we have one test, we used one sample t-test. and 2 sample independent t-tests. Then we took the regression analysis for a causal relationship. Ladies and gentlemen, this is really a brief of what we were able to. Thank you from my side. I will stop, but I need Mohammed Hajar to intervene. This guy is keeping clicking and trying, called Mohammed, to control my screen. This is why he was like interfering everything in. And thank you very much, ladies and gentlemen. I'm waiting for your questions.
Thank you,
Mohammed Hajar.
Thank you so much, Dr. Wosfy, for your presentation. Actually, we have been trying to block most of them, and we have been blocked most of them, but still we do have some problem in this webinar today. We are really apologize for some of them that we did something wrong in here. Now we're gonna start for our questions.
Yes, please.
One by one, and you can answer them briefly, Dr. Wosfy. We're gonna start from the first one, Dr. Zawdat. You can unmute your mic, Dr. Zawdat. Start, please. Please. Dr. Zawdat, ask to unmute. Are you here?
Now, yes. Thank you so much, and thanks for nice presentation for Dr. Wosfy and for your. Just I have question for Dr. Wosfy regarding the test of reliability. If our data is skill, how we can make reliability, or if our data is Likert scale and categorical, how you make the reliability test. Thanks so much.
Thank you very much. Let's make another webinar if the time comes. Very shortly, we have Crumbach alpha test. We will make it in another. Mohammed Hajar, please take this note to make another for reliability and sensitivity and the rest, because it will take time. And
yes,
I'm very grateful for this wonderful question, but it's the Crumbach alpha test. Whenever it exceeds, some scientists say when it exceeds 0.6, that means it's reliable, so you can rely on the results. Wherever it was a Likert test or I mean a Likert category or whatever. We will come in detail to this. Thank you very much for this question.
Okay, thanks, Doctor.
Thank you. The next one would be Dr. Samba.
I'll stop sharing this because, you know, he's trying to intervene now. I guess he stopped intervening to my PC now. He stopped.
Okay. I'm sorry about that, doctor.
No, it's okay.
Second one. Does anyone has a question? Yes, Dr.
Yes.
Sima.
Assalamualaikum.
Salam.
Sir, I want to know how we would calculate pooled standard error by using SPSS.
Say it again, please.
How would we calculate pooled standard error?
Okay, how we calculate standard error using SPSS. We have too many places. I hear you broken. Can you say it again, please?
I'm asking, sir, how we will calculate standard, that is pooled standard error. If we are having the multiple data, suppose we have the triplicate values of each treatment group, then how we are going to calculate the pooled standard error for all the data?
Okay. If we are studying the mean differences, yes, if we are studying the mean differences between two means, so there is in the t-test, according to the equal and unequal, if you remember, we discussed this very fast. when if we assume that both of them are equal, so we take the pooled. The other side, no, if it's not pooled. The very same story goes if we want to study for the variance, not the mean. Again, we have the pooled when we assume that the both populations are coming from the same population. We will take these notes into consideration, and we hope if we have plenty of time, maybe in the next sessions, we will do this on SPSS for all of you. Thank you.
Okay, sir. Thank you, sir.
Thank you, doctor. Thank you.
The next one would be Dr. Dastan Tariq.
Hello.
Hello,
Yes,
you
doctor.
can say.
Yeah. Thank you so much, Dr. Rossi, for a nice webinar. I'm asking about the Pearson correlation and Spearman's correlation. In which cases we can use it correctly?
Okay.
And also, I have another question about the types of data. As we know, we have 4 types of data, but with the main differences between categorical data with the interval and ratio.
Okay. Let me first of all talk about the types of variables. And what was the first question, kindly?
Difference between Pearson and Spearman correlation.
Okay. Let's discuss the variables first of all. We have 3 major types of variables. Sometimes the ratio is regarded as nominal. Sometimes it's regarded as measure. We don't care. But we have a scale variable, or sometimes it's called measurable. Sometimes it's called interval variable that has got a measure. For example, weight is measured by kilograms, so it has a measure. If we go to the second type of variables, it's nominal. Nominal, that specific variable that has no measure, like gender, we say male or female, or marital status, whatever. The other one is ordinal. The third type, ordinal, is a nominal, but it can be ordered or it can be sorted. While gender, for this example, we cannot sort. So these 3 main types. Some of the scientists would regard interval as a 4th. But when you have a ratio, whatever a variable you are using, dividing one to another. I was asked, Mamustahajar, to answer sometimes in Kurdish, but I'm sorry, I cannot. Okay.
You can do it.
Yes. So when we take the ratio, it's still some scientists claim it's still scale, although the division is there, but it's still scale, so it can be regarded as a scale variable, and whatever goes to scale goes to the ratio. Let's go back to the correlation. We have a correlation as we claimed, or as we explained, that correlation is used when we have association between 2 variables. Both of them are scale. The Spearman and the other one is different in what? If we are having categorical data, we are going to use the Kindle. If we are not having the categorical scale versus scale, we're going to use Spearman. Pearson. Pearson versus Spearman. Okay. Thank you.
Thank you. The next questions would be Dr. Shams. Dr. Shams. Dr. Shams, yes, come in.
Hello. Do you have my voice?
Yes, I hear you. 5 by 5, Dr. Shamsul Hayat.
Thank you, Dr. Wosfy, for a brilliant presentation.
Thank you.
I have a question regarding the Kendall-Tau and Spearman correlation. Like, when we have to use go for the candle tab, and when we have to use the Spearman correlation. Any specific difference between these two tests? Though both are related to ordinal data, but
this is absolutely true. This is absolutely true. You know, as you noticed, we did not go forward that much with the order, but let's make a part. The next webinar, let's talk about, as those colleagues asked from us, the reliability analysis, and let's do some ordinal differences between the Kindle Tau beat, Kindle Tau C, and some non-parametric tests. Mama Stajder, I want you to state these, please, for all of us. Some non-parametric tests, and what are those tests used for? Because there are really too many tests in statistics. If we take them in one webinar, we cannot make it. But I promise, for the next lecture, webinar, we will take these tests into consideration, plus the non-parametric tests as well. Thank you, Dr. Shamsul Hayat, for this wonderful question. Thank you.
Thank you so much, Doctor. I've been writing every notes we're gonna do in
for the next. Yes,
webinar.
Thank you. Let's prepare ourselves for these wonderful questions.
Okay, Ustaz Amir. Yes, you can start your questions.
First of all, I want to thank you very much, Dr. Wosfi, and I don't know why you was mentioning my name, because I was listening to the presentation from the beginning.
I don't hear Mamusta Amir.
Could you allow your...
Doctor, did you hear me very well now?
Yeah,
yes. Now your voice is better, yes.
Yeah, Dr. Wosfi, thank you very much for your good presentation, and very interesting. And I don't know why you was mentioning my name in the beginning, because I was listening to you till now. But I thanks to God you finalized in the end who was writing on the board, because I respect you very well. I know you very well from like nearly. So just want to clear this one for you. Second thing, I have a question regarding the statistic. So how we will choose the best way for the statistic, like in terms of the types of the analysis, for example, chi-square, ANOVA, t-test, and all others. Thank you very much for you, Doctor.
Thank you, Mamusta Amir. I would first of all apologize for all this inconvenience that has happened to all of us. But when this guy was writing something on the screen, your name was appearing the very same time.
Yes, that's
I'm
true.
sorry. I mean no harm to you, Mamusta Amir. You are a very respectful man, but your name was appearing. This guy was really professional in interfering, and he was stopping me from clicking on my PC. I mean, at this extent, I'm really sorry for this inconvenience. Again, I apologize for that. The other question was, when do we use the chi-square and what was the other one, Mamusta Amir?
ANOVA.
ANOVA. We said we have chi-square if we want to have association between two variables. Chi-square is scale versus scale, while ANOVA, when we have comparison more than two groups, we want to make a comparison between 3, 4, whatever groups. Yes.
Thank you so much, Dr. Wosfi. Also, I have written something in the box chat that this is not Ustaz Amir did some scratching on the window, and we do apologize for him again. Next one would be Dr. Dara. Please, you can start your question, Dr. Dara.
Okay, thank you so much. Do you hear me?
Yes.
Yes, sir. We hear you 5 by 5.
Assalamu alaikum, Doctor. How are you? Thank you so much, Doctor.
How are you, sir? How are you?
Professor, we always proud of you, Doctor.
We are proud of you as well.
Thank you so much, Doctor. Just I have a suggestion. If you have a time, we will need about the factorial analysis and another webinar regarding the time series analysis. We will appreciate if you can help us for that.
Okay, by all means. Mama Stahajar, are you writing these?
Yes. I'm still writing.
Okay.
This will be great, Doctor.
Thank you. By all means, we will
Thank you
do that.
so much. Thanks.
We will do that.
It was very informative, Doctor. Thank you so much. And thanks
Thank
for
you.
the
I'm very
coordinators.
sorry it was a bit fast, but I was forced to because we want to gain time.
Thank you so much. No,
Thank you so much.
it was very good. Thank you so much, Doctor. Thank you. Ma'am.
Thank you.
Thank you so much, Dr. Dara. Please, anyone, if you have any questions, please just raise your hand.
Dr. Shamsul Hayat wants more webinars about these tests. We promised him and we will keep our promises, no worries.
Yeah. I know we will have a bunch of the webinars in the future. Yeah.
Yes,
one
we
by
are
one.
ready for it.
One by one, inshallah. Yeah.
Inshallah.
I think no more have any questions, Doctor. You can stop our webinar. In the end, I would like again thank you to Assistant Professor Dr. Wosfi, who is a Vice President of Administration and Finance at Tishk International University. Also, for sure, he's my supervisor in PhD. I'm so grateful that today he was with us to present his seminar or his webinar entitled How to Choose the Best Statistical Analysis in Statistics Using SPSS. Again and again, we are so proud for him that he's working for us to present some of the beneficial tools or beneficial subjects in statistics. In the end, I would say again, thank you so much for everyone who participated in this webinar. And then I would like to say, Dr. Wosfi, if you do have any more words or comments in the end, you can say it and then you can say goodbye to everyone.
Thank you very much. I'm really proud to be a part of this wonderful webinar and am a part of this wonderful bunch of fellow scientists. I'm really proud of all of you one by one. And thank you for Stat Office always offering such wonderful opportunities to help and to support others. And I'm on behalf of Stat Office, if I may, apologize for this inconvenience that this bad guy has interfered. I'm really sorry, but all of you, Shiraz Abdul Khaliq, thank you very much. Thank you very much for participation of everybody, for your wonderful questions, and we are promising we will continue in supporting, and whatever you have, just contact Stat Office, and whatever you want, we will do it, all of us, all together. Thank you very much. Bye from my side. Das vidania.
Goodbye to everyone.
Goodbye. All the best.